All right, so quiz 2. Label each molecule below as either a nucleophile or electrophile, and then circle the atom in each molecule that's either electron poor or electron rich. So this is an electrophile. It's electrophilic because the boron doesn't have a full octet. So the boron is electrophilic. That's the most electrophilic spot. HCl is electrophile. It's a strong acid, really one of those reactive acids. So the H is the part that's electrophilic. Even though the chlorine has lots of lone pairs, it's really not a nucleophile. This is a nucleophile. The sulfur is electron rich, has 2 lone pairs. So that's the nucleophile. And then a pi bond. This is an alkyne. And you could have circled the carbons or the pi bond, however you want to do it. Remember, pi bonds are nucleophiles as well. So that's either one of these carbons would have been fine as labeling that. Here, draw the mechanism arrows on the starting materials to form the products. So given the products, this carbon is nucleophile. Had to show that CH bond there, had to draw that in. 2 arrows, deprotonate, electrons going there, lone pair there. And the question is, will the starting materials or the products be favored? And then use a picture. So again, asking you to use a picture. So what's the difference here? sp hybridized, sp2. So this was an sp orbital. So starting materials are favored. That was worth 1 point because of hybridization state. Then I want to see, draw an sp orbital. Say the sp orbital is closer to the positively charged nucleus. It's better able to stabilize negative charge. Right? The size of the hybrid orbital matters here, and that's why this is a more favored. So the starting materials are favored here. So knowing those factors that affect acidity and how to isolate them. All right, so we continue on that acid-base trend. Label these below as acid or base. So negative charge, that's the base. This would have to be the acid then. Draw the mechanism arrows. So lone pairs, grab the lone pairs, deprotonate the H. Get the O minus, draw the products. So correct products and make sure you have the right charge. And then which side of the equilibrium is favored? A lot of folks got confused on this. A lot of people thought that the products would be favored. It's actually going to be the starting material. So yes, this can do resonance, which is great. But this also does resonance, but does resonance in a really special way. It's actually aromatic. And aromaticity is very, very stabilizing. It's like super resonance. So the actual favor over here, why is this aromatic? It's in a ring, uninterrupted p orbital system. This carbon is choosing to be sp2 hybridized. So that lone pair is in a p orbital. That lone pair then can do resonance with this. It's in a ring, uninterrupted system. 1, 2, 3 odd pairs of electrons. That's aromatic. So that's the key factor for equilibrium here. So things to look at for equilibrium, things like aromaticity, resonance, all that kind of stuff.